Let's talk in more detail about Osmose and MIDI polyphonic expression MPE, particularly how you interface to Osmose using MPE. Now, Osmose right now runs 10.09 Hocken Editor and DSP firmware. So this discussion also can apply to continuums that run that, but since most continuums are running 10.4x right now, there will be some changes in that alter what I'm saying a little bit. We're only really interested in the MIDI interface to Osmose for this discussion. As a short recap, the Osmose has either DIN ports, DIN in and out, or a USB port that can be used to record and play back MPE data. Now, the USB port has two virtual ports assigned to it. There's a USB 1 port that's used for setting the Expressive E external MIDI modes, MPE mode, multi-channel mode, classic keyboard mode, and poly aftertouch mode. So if you're going to record MPE and play it to some MPE device on the external port, say an MPE plugin or an MPE synth, you'll use the external MPE option. To record and play back to the Osmose, you'll use port 2, which is using the Hocken MPE Plus protocol. This is MPE with a little bit of extra stuff added to support extended resolution that the continuum was intended to support. Some of this MPE Plus makes sense for Osmose. Some of it is a little less applicable than on a continuum keyboard, but still port 2 is MPE Plus on the Osmose. Now, what is MPE? We can summarize this in a few bullets. MPE uses single monophonic voice per channel output on MPE channels, which are typically, for the Osmose and for continuum, channels 2 to max polyphony plus 1. Most Osmose presets are polyphony 2 plus, the plus meaning expanded polyphony that multiplies the base polyphony 2 times your DSP number, which for the Osmose is 6. So if you see polyphony 2 plus on the Osmose, that means there are 12 MPE voices that can be supported. If you try and play 13 voices or more, you'll have drop notes if the preset is set for that polyphony. Now, each polyphonic key press outputs on a different MPE channel in the default MPE priority used on the Osmose. You can change this in the editor, as we'll see, but for the most part, you can think of it being a round robin. When you press a key on the Osmose, you'll output, say, on channel 2, and then you press it again, you'll output on channel 3. If you press 3 keys together, you'll output on channels 2, 3, and 4, etc. Channel pressure is used to initiate volume on the Osmose. MIDI velocity is not used at all. Now, if you set external MPE mode, you'll output velocity with your MPE data, and you can also set what CC or what MIDI message you use for your pressure in external MPE mode. In MPE Plus mode, channel pressure is always going to be used for your pressure. Pitch bend is also output per channel. Every note will have its own pitch bends, so you can bend one note up on one key and one note down at the same time. That's one of the great things about MPE, independence of output per key. Aftertouch on the Osmose, CC74 is also output per channel. Of course, on the Osmose, CC74 triggers after the channel pressure area. On a continuum, CC74 is tied to front to back motion, as it is on a Rolly Rise or a Linstrument, for example. We have to be careful with the term aftertouch because sometimes that's used to mean different things. Osmose also supports global pitch bend using this global pitch bend slider. Global pitch bend is output on channel 1 and it affects all channels. So you can have your individual key pitch bend active and as a second order bend, use the global bend on top of that to bend all of your channels up or down the same amount. Another thing to understand about MPE is that bend, channel pressure, and aftertouch messages are sent before the initial MIDI note on. Then there's MPE Plus. MPE Plus uses all of the MPE characteristics we just discussed, but it also, as its main component, outputs CC87 for pitch messages, channel pressure messages, and aftertouch CC74 messages. And this extra byte, this extra CC87 MIDI byte, allows for increased resolution, 21 bits for pitch, 14 bits for pressure, and 14 bits for aftertouch. Now the sound engine will play if you send it MPE Plus or MPE. The difference is if you only send it MPE, that perhaps you recorded an external MIDI mode, you're not going to get that extra resolution that MPE Plus provides. So if you want to record and play back to the Osmose and you want it to sound as close as possible as the audio output when you play the keys, you must record and play back MPE Plus, because that extra resolution can be important to affecting the sound. Now, when you're using a DAW for recording this MPE information, you need a DAW that's going to process MPE. You can't just record normal MIDI information as standard MIDI and play it back to the Osmose. You're going to get all kinds of note dropouts and audio discontinuities. And when you record, for example, here's the Cubase recording of MPE data, you'll see that each note, when you play it, is assigned to a different channel. Channel 3 is assigned to the first note, and that has aftertouch data that's recorded and played back. There's pitch bend data, and there's brightness, CC74 data. Of course, here, aftertouch in Cubase means channel pressure, whereas brightness means Osmose aftertouch. This is why sometimes the terminology can get a little confusing. If I play a chord using MPE output, each note in the chord is going to get its own channel. In this way, note per channel applies. You'll never have anything more than a single monophonic note per channel. Now, if you just happen to try and play back normal MIDI to an MPE device like the Osmose, when you record MIDI in a DAW, if you play a slur, it can overlap the notes on the channel. Now, a lot of plugins easily can support this, but Egan Matrix will hiccup if you try and play back on one MIDI channel this kind of thing. If you want to record notes on the same channel, they have to be separated by each other. They cannot overlap. Also, if you try and play chords on one channel, you're going to have dropouts and other discontinuities because you can only have one voice per channel. If you try and send standard velocity to Osmose and no channel pressure data, you won't get any sound at all, because Osmose needs channel pressure data to initiate your volume response. This is also why velocity is always set as 127 to its max value in your MPE Plus mode, because the sound engine doesn't use velocity. Now, you can change this in the editor to use dynamic velocity, but there's absolutely no reason to use MPE Plus anymore unless you are recording and playing back to the Osmose, because now the external MIDI modes support arpeggiator, it supports pressure glide, so there's no reason to ever use anything but external MIDI mode when you're playing some external MPE instrument or plugin. What does this data look like as a stream? It's an enormous amount of data output from port 2. Here you can see a little MIDI recording in a MIDI monitor. In 10.09, only pitch bend and channel aftertouch, this means channel pressure in this case, are sent before note on. In 10.4x, this has changed. This is actually a little bit of a bug. You really want your CC74 channel pressure and pitch bend sent as the initial values before note on, so the MPE drivers can initiate the note to the right values. Some plugins might not respond correctly if you send them MPE Plus data for this reason. So again, if you're using a plugin, use the port 1 MPE to play that. Don't use MPE Plus. No plugin's going to support the extra CC87 resolution anyway. Also, you'll notice when you record on the Osmose Hawken port, you'll get other CC's output in addition to CC87. You can see CC117, that's used as a MIDI loop detect, and it will actually put out a MIDI loop error if you record and play that back. This, to me, I think really should be changed because when you're using a DAW, there really is no MIDI loop here. But just beware of that. When you get that MIDI loop message, most of the times it's because you've recorded and played back this CC117 message. There's also CC111 that's used for handshaking with the editor. And if you have the editor up, you also might see other CCs like CC114, CC116 that are used for internal communications to the editor. Obviously, you'll see all these extra messages in here that I've color-coded. If we just look at the output from port 1, you're only going to see your standard channel pressure. In this case, I haven't used bend or CC74, but those will be output as well. If I take a look at MPE Plus output that uses bend and aftertouch, of course, aftertouch is only going to come in after your max pressure has been achieved on the Osmose. This is just a very short segment here, as quick as I can play a note. So you'll find that there's going to be an enormous amount of MPE data that'll be generated for MPE Plus output. Some MIDI recorders may not be able to handle that huge MIDI stream. Now, next thing to talk about is Osmose polyphony and also priority. Osmose has a bass polyphony displayed when you bring up the editor for a preset. Here, one I've created myself, bass 4. It also has a priority here, oldest. Now, some of the Osmose presets are set to polyphony 2 plus. Plus, as we said before, means expanded polyphony. That multiplies your DSP number times your bass polyphony to give you the actual MPE voices. Since Osmose is a 6x DSP instrument, Bass 2 Plus will give you 2 times 6 or 12 MPE voices. Bass 3 will give you 3 times 6 or 18 MPE voices. But Osmose can only output a max of 13 voices right now because channels 15 and 16 are reserved. In the future, you'll be able to output on all MPE voices 2 to 16 when 10.4x is available for Osmose. Now, most presets are set polyphony 2 plus, so most presets will be outputting on channels 2 to 13, and you also cannot input on any channels that are outside that as well, or you'll get drop notes. You can always look in the editor at your DSP usage. That'll show you what each of your, in this case, 3 DSPs that are each 2x DSPs to give you a total of 6x, what each DSP is doing in terms of processor usage. If this number starts getting up in the 80s or 90s, you might start seeing a reduced polyphony message come out on your editor screen, and that's a good indication to go in there. And if it says 2 plus, reduce it to 1 plus, or if it's 3 plus, reduce it to 2 plus. Red text in the editor means it's a control. Normally you can click on that and change it to some value. Here we can go in and change it to one of my polyphony numbers. Now, you'll notice there's a difference between DSP usage and MIDI usage. Normally that's the same until you get to a point where your DSP number might exceed the actual number of MP voices you can output. In this case, a 3 plus preset has a DSP number of 18. So the internal DSP voices that can be used for processing are still 18, but the external MIDI voices that you can have are only 13 in this case. Those internal DSP voices can affect the actual internal programming of a preset and how the internal eigenmatrix constructs are used. Now we can talk about MPE priority. This has to do with how the MPE voices are output. Now, Osmose as a default uses a round robin like priority, This means if you output on MPE voice 2, the next one you'll probably output on is 3, 4, 5, until you cycle all the way around to 13. You'll come back to 2. The DSP actually uses what's called oldest priority. This will play the oldest voice in your MPE data stream. It may not always go in sequence, depends on what voice things ended on, but for the most part, oldest priority can be thought of as round robin. Now you can also set lowest priority. Lowest priority means if I play 3 notes, they won't round robin across all the MPE channels. They'll only play starting from the lowest MPE voice, which is normally voice 2. So if I play a 3-note chord, I'll always be playing channels 2, 3, and 4. If I play a 4-note chord, I'll play channels 2, 3, 4, and 5, and those notes will be played in the order that the eigenmatrix detects the Osmose keys being played. Now, same priority is kind of like lowest, but it will always play the same note on the same channel for whatever you press up to your max polyphony. Now, if I go past the max number of MPE channels, the earliest note I played in that sequence will be reassigned to the next note, and then when I play that first note again, that will be reassigned to another MIDI channel. So same priority always plays the same MPE voice per note up to max MPE channels, then it will start a round robin after that. Osmose used to use same as a default, but it now uses round robin. Then there's high end priorities. High-end priorities will always play the highest MPE voice in your polyphony. So if my polyphony is 2+, I can play 13 channels. The highest 4, if I set for high 4, would be channels 10, 11, 12, and 13. If I set high 3, it would only be 11, 12, 13, etc. We can see that if I play some notes on the Osmose keyboard and look at each of the priorities, if I play C, E, G, then D, F, A, and then E, G, and B, in oldest priority, because I'm always cycling through all of the MPE channels in my polyphony, and then when I get to the end, I will just round robin back again. You'll see that each of the channels, because I've only played 9 voices, will get its own unique MPE channel. If I continuously play a C and no other notes, that will cycle through all the notes as well. What about lowest priority? Lowest priority, if I play the same thing, I will always get channels 2, 3, and 4 because I'm always playing the lowest end channels I play within my polyphony. Of course, they might not always come out 3, 4, 2, 3, 4, 2. Maybe I pressed 2 earlier on the last sequence, and 4 came in next, and 3 came in next. I'll always have channels 2, 3, and 4, but they might not always be assigned to the same note. If you want that, that's where same priority comes in. Here, I will always play the same notes up to my max polyphony. So a C will be channel 3 when that comes in. It starts on whatever channel is available. 4 will be an E. 2 will be a G. Then 9, 11, and 10 for my DFA chord. Now, on E, G, and B, because E's already been played and assigned, E will be what it was before, channel 4. G will be what it first came in on, as the same priority, channel 2. B is now a unique new note, so that'll be assigned a new channel 7. High 1 priority is only going to play the highest channel in your polyphony, in this case, channel 13 if I have a 2+ polyphony preset, and it will ignore playing chords. It'll see whatever the first note you played in your chord is, and it'll output that on the highest channel, in this case, channel 13. Now, if I want to play a 3-note chord, I'll set high 3 priority, or maybe high 4 even, because that'll allow me to play 3 or 4-note chords. In this case, no matter what chord I play, I'm only going to be playing on channels 11, 12, and 13. They might not always be in order 11, 12, 13 on the notes I play, because the keyboard will sense whatever note's playing first and assign that high channel first. Why might I want to use low and high priority? Why not just always set things to the default? Well, as it turns out, you can play some tricks using lowest plus highest priority to allow you to multi-track, or actually duo-track, an MPE DAW recording. Remember that the Osmose and Continuum are not polytimbral instruments. You can only play the one preset that is loaded if you're playing it back from a DAW. But what I could do is I could create a virtual split point. I'm not going to create a real split. I'll create a virtual split point on my Osmose. And I'll have a lowest preset assigned when I play the low track, and I'll have a high 4 preset selected when I play the high voices. Now, if I'm using a 2+ polyphony preset that doesn't use increased computation rate, because if you see a preset with this little caret in the editor for its polyphony, that means it uses increased computation, and that will half the polyphony that's available. Just be aware of that. In this case, I'll be able to play channels 2 to 9 on my lowest, because I don't want to play past channel 9, because I want to reserve channels 10 to 13 for the high 4. So I can play up to 8 voices on the bottom here and 4 voices together on the top. And typically, in this case, of course, for the bass notes, you're not going to have that kind of polyphony working, but it'll still allow you to do multi-track recording and play both tracks back to the port 2 Haken port, and you'll be able to, let's say you want to record one complex thing on the bottom and another complex thing on the top, and you can't do that with both hands. In this case, you can do it individually and play them both back, and as long as there's no notes overlapping, you'll be fine. To do this, what you'll want to do is, in the editor, set priority lowest on a preset and save it to a user position, set priority to high 4 on a preset, save that in the user position, determine what your virtual split point is going to be, and remember what that is, and then bring up the preset that's set lowest, then record your MPE in a DAW the way you always do, and make sure that you play no more than the number of voices that can be allocated for the lowest track. Here 8, but you probably will play a lot less than that. And make sure that you do not play anything above the split point, because we don't want to try and play the same note at the same time on 2 different channels. That can cause some issues too. Then when you're done with your recording for your lowest priority track, bring up your preset that's set to high 4 and do the same thing. Only now you're going to be playing above your virtual split point when you record. By the way, you can use octave down when you're playing the lowest. You can use octave up when you're playing the highest, as long as you don't try and overlap the same octave on both of your split points. Now when you have your recording here, you can play them both back to the same Osmose port 2, and you should be fine in terms of playing the MPE, because there won't be no MPE channel overlapping. And that's a nice trick that you can use, and why, by the way, that high 4 was originally added. You will not see this number of priority options in a lot of MPE implementations. Now on pressure glide, you have to be a little careful, because if you set pressure glide to some presets, you might not get the polyphony coming at you expect. The tin whistle is a good example of this. Tin whistle sets a mono mode, which is setting pressure glide, to the interval maximum. So no matter where you play on your keyboard, glide will be active for the entire thing. This will in effect create a monophonic voice. Since you'll never be able to play 2 notes together, glide's active for the whole keyboard. Same priority is also set on this, so setting a high glide could affect how you perceive the MPE polyphony when you're playing. Channel 1 input mode. The Osmose and Continuum have a special feature where if you have a controller that's not an MPE controller, a standard MIDI keyboard, for example, or maybe a beat step sequencer, you can play standard MIDI on channel 1 and it will accept it. Don't try and play on channel 1 and on MPE channels at the same time. You can have some issues developing there, though at times that can work. So basically, send your standard MIDI on channel 1. You can play up to the max polyphony of your preset. You're still not going to be able to play more than 12 polyphonic voices on channel 1 in a 2+ polyphony preset. Some presets, by the way, have lesser polyphony, so you just have to look at your preset polyphony, and again, if it's using the increased computation rate, that'll half the number of MPE voices you have available. This will process your note on and note off velocities. If you're using polyphonic aftertouch, real polyphonic aftertouch, that should be processed on channel 1 mode if you have a keyboard that supports that, for example. Of course, if you have an Osmose, you already have the MPE keyboard you need, and you can still use the global bend on channel 1. Well, there's MIDI I/O settings in the editor. Don't change your MIDI I/O settings for anything except this X bend range. What this is setting what your maximum global bend range is, and that defaults to 12. So when you use that global pitch bend slider, that will by default bend up an octave and down an octave, but you can set that for less. If you go into the editor, you can set it for 2, which will bend up and down a major second. You can set it for 5, which will bend up and down a perfect fourth. You can set it for 7, that'll bend up and down a perfect fifth. Oops, I had an error there. And in 10.4x firmware, you can set this through external MIDI operations to other intervals, but that's for a discussion later on. But you may want to set that global bend to a lesser value, and this is the only way you really can do it right now. Let's end with a few use cases. Here's an option that you can set in the editor, a MIDI split. There's a lot of split options that are still available in the editor. They really were intended to be deleted, but they're still there. The only two options you want to use in terms of a split are these two in the middle here. Split internal sound and MIDI out. This will allow you to select a split point that you can set in your editor. You can drag these two triangles left and right to move that split point. And then you can select whether you want your internal sound to be below the split point or above the split point. And what this will do is, if you set your internal sound below the split point, when you play beneath that, you'll be playing whatever your preset is, but above that will be output on MPE MIDI channels. So if you want, you can, say, as I've done here, connect up a Egan Matrix Micro, and here I've set that in the editor to be an external output device, or I can go into the editor for the micro and set the Osmose to be the input device. Either one will work. And what this will do is it will output to the micro above your split and play internally below your split, and in this way you can kind of get a multi-timbral effect where you can play a melody on the micro above using one preset, and you can play your bass using an internal preset. You can switch that around, of course, if you want, and split it so that your MPE output is below the split point. Maybe you want your external synth to play a bass line, and you want to play polyphonic MPE on your internal sound above the split point. That's up to you. In this case, I've gotten rid of the computer and I've put a USB MIDI host in the mix, and now I can play the micro without that editor being involved. I can set my split, get out of the editor, save the preset that I want with the split on the Osmose so that I can call it up later and you'll be in business. This will output on whatever MIDI channels that you are outputting on your Osmose. Of course, the micro only supports a max of 8 in terms of MPE polyphony, but the micro running 10.44 will accept MIDI on any channel 2 to 16, and it will automatically allocate your polyphony up to a max of 8. That's kind of the way we want Osmose to operate too, so we can use, for example, the Studio One DAW, which outputs MPE on all channels. You can't use that right now because in 10.09 you can't send MPE to the Osmose on any channel higher than its max polyphony. 10.44 will take care of that, and so it'll allow the Osmose to receive on any MPE channel and play up to its max polyphony. So there's another use case that we can talk about. Finally, we can play Osmose with a instrument. In this case, you can hook up your instrument to the DIN in of the Osmose. Set that to 2.5 DSP in, which you need to set if you're playing the sound engine on the DIN. If I want, I can send the DIN output to another device. Here I send it to a USB MIDI host that connects up to my Egonmetrix Micro, and I set the DIN now for 4.5, which is DSP in, but also send the output to the output port. So now I can play my instrument and it will play both the Osmose sound engine and the micro at the same time. So you can set up some combination splits in this way. You set the instrument up as per these settings. All this stuff is available in the Osmose cookbook, so you can bring that up and get your instrument settings. If you want, you can set the instrument as an external music data instrument in the editor and play it through the editor that way. One thing to note in 10.09, if you connect up pedals to your instrument or pedals to your external controllers, that pedal information is not processed right now in the Egonmetrix. In 10.40 and later it is. So in 10.4x, when that's available for Osmose, you'll be able to connect up your pedal to your instrument and that'll pass the data through. Finally, you can do a similar thing with a Rolly. Connect that up in a similar way if you want. The only thing about a Rolly is Rolly, like Studio One, does not let you set an end channel for MPE right now. It will cycle through all your channels, and so you cannot use Rolly in 10.09 setup as MPE. For Rolly, you'll set multi-channel mode. On there, you can set your channel max, and in that way, you can set it up like it's an MPE device with the same channel pressure, CC74 band set to 96, which is what you'll want to set for both the instrument and the Rolly or any MPE controller that you're using. Set it for band 96. And that is kind of a quick summary of MPE for the Osmose.